Let's talk about reducing the risk of electrical systems development in the aerospace industry. Retaining program profitability is a significant challenge today, and there are a lot of competitive pressures. We see substantial pressure on margins coming from industry players throughout the ecosystem. We're all trying to achieve cost control, both in our development programs and in our manufacturing efforts. This also includes getting quality right the first time. As you may know, most of the work done in aerospace is on a program basis. We're always trying to balance the amount of innovation against the risk introduced into a program. The risks that we face manifest as both cost and schedule overruns, and these impact people who are responsible for those programs. Individuals like the vice president of programs or the program managers running specific platform development activities. From a technical perspective, there's always a set of commitments that we make. When these come under risk, they jeopardize the reputation of the company because it's what we deliver technically that our customers are looking to acquire. One of the things making this more difficult is the trend toward implementing platform functions electrically. What we've seen over the past 10 years or so is a major shift from implementing platform functionality using mechanical, hydraulic, and pneumatic approaches to electric. An interesting example of this is a company called Boom Supersonic. In their supersonic aircraft, Boom is able to replace the canted nose of the Concorde with an electronic vision system that allows pilots to land without having to cant the nose forward. This is reducing the cost of supersonic transport, which might make it possible for people like us to actually fly in a supersonic jet someday. Why is this happening? Well, we discovered that when you replace mechanical implementations with electrical, you increase the overall reliability of the platform. You make it more maintainable. You also reduce the weight of the platform, which means you can transfer weight from infrastructure into payload, or trade it off for longer range or higher fuel efficiency. This is extremely important because aircraft are limited in how long they can stay up in the air and what they can do while in flight. If you can replace aircraft infrastructure with mission systems, you can do a lot of interesting things. You can carry people further, you can take more cargo, and enable new approaches to the commercial air transport industry. How extensive is this shift to electrical? It turns out in the past 50 years, we've seen an increase in power generation on platforms by a factor of 10. This is extremely high, given the fact that we haven't really changed the form factor or the size of those platforms. The power density has gone way up. As we increase the electronic content of the platform, we've also increased the complexity of the electrical system. At the same time, and this is key, we've continued to use design and integration approaches that were optimized for mechanical implementations. This is why digitalization is so important today. What does it mean to digitalize? It means to make effective use of digital technology to improve overall work processes. But it goes beyond just digitizing the data and storing it electronically. It's more about creating useful models of a platform, its electrical system, and the information shared between different elements of the different mission and flight systems. When we digitalize, we actually bring about virtual design and virtual systems integration that allows us to do things like model-based systems engineering, model-based design, model-based manufacturing, and model-based sustaining. The three key tenets of the model-based enterprise are digitalization, automation, and data reuse. In digitalization, we use digital models as the authoritative source of information shared across the entire development and manufacturing value chain. In automation, we use software algorithms to transform these models into correct by construction forms that help us drive the next stage in the value chain. Finally, what is data reuse? It's the ability to take data that we've put into our digital model and the electronics that are part of it and use it in subsequent stages of the value chain. Incidentally, one of the big advantages of data reuse is that we eliminate error associated with either manual reentry or sometimes incorrect data migration from one stage to another. The errors that arise here are really quite significant and are often a deep source of the elements that go wrong and end up becoming the drivers of program execution risk. In response to this, we've developed the Capital suite of systems design and integration tools. Capital implements the electrical model-based enterprise. It is a mature environment. We've spent thousands of man-hours and over 20 years to get this right, and it's architected in order to exploit digital data continuity, which allows us to build a comprehensive digital twin of the product, production, and its operation, and then connect that twin across the value chain by a comprehensive digital thread. This lets you perform activities seamlessly from the definition stage, through design, into manufacturing, and then through the sustainment and maintenance of the overall aircraft electrical system. We've also recognized the need to work with other disciplines as the design of the electrical system progresses. We've enabled Capital to work closely with mechanical CAD environments and integrate with popular product lifecycle management tools. Tight integration between the electrical and mechanical design environments allows our people to work together quickly and in real time. This means they can pass off revision-controlled versions of their work to their counterpart, so everyone knows who just received the right data and who's up next to do his or her work. This reduces program risk because there are fewer errors. These two folks converge on their ultimate solution more quickly, and they do it in a way that ultimately results in a systems platform that is easier to build. What are the business and operational benefits of using Capital? Of course, there are significant reductions in cost, but I think what's more important is that we extract program risk from our work. What do I mean by that? One of our customers has been able to reduce the number of changes found during systems integration by a factor of 10. If we think about how programs go wrong, it's often associated with finding changes at a late stage of the integration phase. This group was designing a flight simulator. They were able to reduce those changes by 90%. That's a huge amount of risk buy-down from just having accurate information passed from one design stage to the next. In a second example, one of our customers designed a space capsule from scratch using Capital. They designed its entire electrical system, from capturing the logic, to specifying the interconnect, to detailing the harnesses. When the harnesses were received from manufacturing, they installed them in their prototype capsule. They hooked everything up, and it all fit. First time. When they turned it on, it worked. First time. No question. The advantages of adopting Capital for electric system design are starting to be recognized throughout the industry. In fact, just recently, Boeing invited Siemens to participate in its second century process improvement program. This involved rolling Capital out across the entire Boeing enterprise. What attracted Boeing to Capital was the ability to do electrical system design using a comprehensive digital thread connecting the entire value chain. This reduced significant numbers of errors and allowed Boeing to actually connect design to systems engineering. Not only did this reduce Boeing's costs, but they now live in an environment of reduced risk. They can actually be more innovative when they propose new solutions to their customers. With the increase in electronic content in our platforms, we've reached a tipping point where program risk is dominated by electrical system integration. Companies like Bell, Bombardier, Pilatus, and Boeing have all recognized this and have taken advantage of the capabilities Capital brings. I invite you to follow the link below to learn more about what Capital can do and how we can help you as well.